Hey guys, this is Divya, and this video is a quick introduction to the MFM and to my final project that I did for the living computation class at the University of New Mexico. So the MFM, it stands for Movable Feast Machine, which is developed by Dr. Dave Ackley at the University of New Mexico. There's a link to his stuff below. Please check it out. It's really cool. So basically the idea is this machine is a 2D grid of tiles put together in some sort of a brick wall sort of fashion, and it's indefinitely scalable. So you can add in as many tiles as you need or remove as many tiles as you need, and it shouldn't affect the program. You shouldn't have to restart the system or anything like that. So you can see a prototype of the tiles on the right here. They're connected to, so the rightmost tile is connected to one on the bottom and one to the left, and basically they do communicate with each other, but each tile is its own individual, fully functional system. It's pretty robust in the sense that if you, like I said, if you remove tiles or add tiles, it does not affect the program. It is non-deterministic, as in each event given to an atom is completely random, as in you don't know what's going to get an event. And I'll talk about what those are in some upcoming videos. So the MFM simulator looks like this picture on the bottom left here, and let me just give you a quick look at my project in the MFM. So this is what the MFM looks like. Let me show you. Okay, so my project is about sorting atoms using a 2D grid of membranes. So I call these things membranes, and here I'll show you how they work. They grow from a single seed, so I placed down a single box or a membrane atom here, and when I run it, it forms a grid, and the column values, so here if you see x and y are 0, and the column values, which are y, increase as they go, as the grid grows to the right, and the x values or the row values grows or increase as the grid grows downwards. So let me show you the sortie atoms, I'm sorry. So this is how they look. When you first place them down, they're uninitialized, they don't have an x and a y value. But once you run them, they get initialized into a random x and a y, and the membrane atoms try to sort them into their right places. So if we pause for a second and we look at one of these, so the sortie atoms have a 0, 0, and so they're in the 0, 0 membrane. Let's try one of these. This is 3, 2, they're in the 3, 2 membrane. And once they're in the right membrane, the membranes basically lock them down. They don't move anywhere. The only thing is if there's too many of a single type, so if there's too many 3, 2 sorties and they occupied all of the space that the 3, 2 grid the 3, 2 membrane had, then it tries to sort them. It tries to swap more 3, 2s in with the 3, 2s that are already inside the grid. So it does push some of them out, but only to push more of the 3, 2 in. So technically they're gonna stay where they are, as in there's always going to be the same number of atoms in the membrane. So that's mostly it. It responds really well to any kind of attack. So if you take an eraser tool and erase the grid, it self-heals. The sortie atoms do get erased, but I mean, you can always just place more of them down. If you really want to take a look at how these work, you can place, or how well it sorts them, you can place a bunch of sortie atoms down randomly, and it does a pretty good job of sorting them. So if we wait for a little bit, you can see the colors solidifying in the membranes. Like you can see it go from blue to yellow, as in this one, as you can see, is all blue. It'll turn pink down here. It'll be more green to the right and yellow on the bottom. And it takes a little bit of time, and right now it's having trouble because there's too many sortie atoms for the size of each membrane. So let's put down a bigger membrane, or actually let's put down the sortie atoms first, and then a bigger membrane like the 12, which gives it more grid size per membrane. And if we watch it, it does do a pretty good job of sorting them. So this is after about 5 minutes of letting it run. You can see it's sorted everything on the right, pretty much 100%. The only problem with the ones on the left is that there's too many of them. So one more thing I noticed about this is that the bigger the box is, the less it'll sort. Actually, I keep forgetting. Let's put the sortie atoms down first. Yeah, so, and my theory for this is that since the membranes do most of the sorting, I think that the atoms aren't actually getting to the membrane as frequently because they're just on a random walk. So in the future, I definitely like to make the sortie atoms a little bit more smart, make them do some of the sorting themselves, not rely on the membranes as much. But so far, the sorting is actually not too bad. So thank you for listening. I will hopefully have more videos up pretty soon explaining how Ulam works so you can program it yourself. And see you soon.